Greetings, it is I for KI number 5 video. I am Brent. Today we'll be looking at a circuit that transmits an audio signal. The audio signal will be sent through this circuit, as can be seen. The circuit has various items in it. We are only looking at certain green shaded parts because that is to the maximum of our knowledge that we can use for this course. We have a local oscillator, a mixer, a low noise amplifier, a bandpass filter, a diplexer, and an antenna. Let me go through each one individually. Specifically for the class ECE 312, which I am a part of, we can talk about the local oscillator. The local oscillator is just a consistent signal that we use as kind of like a carrier. This will carry our signal that we will amplitude modulate. Our signal is sent directly through the circuit and convolved with the local oscillator. After that local oscillator is the mixer, which does what I just said. After that mixer is a low noise amplifier, which really amplifies that signal because it's really weak, because usually it's just a human voice, and humans are so weak and produce such little signals. So we have to use that amplifier to amplify it with as little noise as possible. After it goes through that amplifier, we see the bandpass filter. That bandpass filter selects a specific band that we want to use in order that we can listen to our voice that we want to send. It is selected to split off from the local oscillator, and this whole entire process is generally called demodulation. When we look at things that want to select certain frequencies, what are we looking at? We're looking at a filter. Now, a filter is just usually a simple circuit. And what's a circuit coming from? That's right, it's coming from ECE 332. So we can see the simple circuit. It has a capacitor and 2 resistors. One of those resistors is providing feedback. The capacitor is basically a pole, and it provides some delay in our circuit. And when we look at the gain of this circuit, we can determine that through the transfer function, it's a filter. This circuit, with the antenna and such and everything I've described, was printed out on this thing. This is called a PCB, and it's also called a balun. Now, once this circuit is printed, how are we going to make an inductor that transforms voltages and even acts as an antenna in some cases? Apparently, there are these pins that are soldered between different layers of the balun, and they act as an inductor. Very small, but very integrated. And the weird twisty parts of the circuit are just the antenna. I am only in 2 classes because I already took ECE 342 and 341 a long time ago. So I only talked about those 2 classes. I really like radio. I listen to it when I'm sick of my own music, and I don't ever listen to AM radio because the quality is just so bad. But it's nice to know how that worked. I listen to FM radio, and another version of radio that is used today more commonly that we listen to music with is just simple Bluetooth radio, which is low energy, BLE. Well, that's only used if you're connecting it to something that's like a smart watch. But when it's connected to your car, it's actual radio. Thank you for watching and listening. I hope you had an enjoyable day. Goodbye.